A primary mission of sequestration.org is the sequestering of carbon from the atmosphere. The manner in which this occurs is through the construction of biochar, which is nothing more than carbon in the form of charcoal. The value of biochar is that it is considered carbon negative in putting carbon back into the soil. To see how this works, let's first see how it is made.
Hi, Koi. Hand me some of that dry blackberry root and let's make some biochar. And I'll show you this little stove while I'm loading it up. So this is a microgasifier. This type is referred to as a T-LUD, or a top-lit updraft stove. But I call this model here the Char Baby. So we put our fuel in, and now we need a little tinder on top to get the process rolling. Once we get this burning, we're going to start running on gas. These things are clean burning and 75% more fuel efficient than an open fire. You'll see why in just a minute.
75% efficiencies over conventional open fires as a cooking source is compelling, but can biochar make good on its claim to replenish depleted soils and the restoration to fertile and productive tilth?
This was a blackberry plant until I dug it out of the ground. It's an invasive species here in the Northwest. But I see it as a perfect feedstock for making charcoal. Charcoal is a perfect mechanism for storing carbon in the ground for thousands of years.
We wanted our control plots to not grow very well, not any better than your average degraded soil. So I hadn't really anticipated something as unimproved as this, most of which will need to be picked out in order to cultivate better.
Now we're going to get this to gasify. So what we need to do is cut off the oxygen to the bottom of the fuel pile. So we'll do that by damping back on our primary air. As we establish heat up here in our pyrolysis zone, we're going to begin to draw in secondary air, or feed the top oxygen. We want the gas to light. We're going to do that by concentrating it with this lid. And in just a few minutes, we'll start to see this thing gasifying.
So what we have here is fairly clayey, kind of a clay sandy loam with a huge quantity of rocks. And that's part of what we were looking for. We were looking to have some soil that we could show some improvement on. Because in addition to wanting to show the recalcitrance of the carbon in the soil, we also would like to illustrate how good the soil can be made, how it can be brought from a poor quality soil like this up to a good soil that we can grow crops on.
It's fair to assume that these low-tech appliances might not find their way into the kitchens of the American household anytime soon. But for those in the third world, such as Nicaragua, cooking over an open-fired hearth is a reality and presents dangers to one's health and a rapid depletion of available resources. Such simple stoves as illustrated here could be a welcome remedy to the needs of the third world. For the developed and industrialized countries, biochar takes on a competitive advantage in comparison with other soil amendments, like fossil fuel-based fertilizers.
To get the real benefit of it, they need to be small pieces. So we'll stuff it in your bag. You can also draw with it, just like artist charcoal. Cool. And this will last for at least hundreds of years in the soil. It's a way to take the carbon out of the atmosphere and store it in the soil for long term. So as far as I can tell, it's one of the few rather low-tech ways to remove carbon dioxide from the atmosphere.
Restoration of soil for healthy tilth, carbon negativity in putting carbon back into the earth, combustion efficiencies and cogeneration of power are some of the paths of biochar. Seachar.org welcomes your participation in finding out what biochar's potential has in store for us.